Good morning, everyone. I request all the students to settle down as quickly as possible. So, in the previous class, we were discussing about Numpy, and we have checked various codes using Numpy. And if we need to perform numerical computations, okay, so Numpy is one of the library which will help us. Okay, it supports numerical computations and linear algebra basically. Okay, so all the algebraic operations are easier here to use the Numpy library. Okay, and in the previous class, I have told that how to organize, how to use Numpy array, how to create a Numpy array, and how to find the index position where that particular element is stored in the memory. Okay, so we have seen the creation of a numpy array, and we have also checked about certain operations which can be performed on the numpy array. Okay, now in today's class we'll carry forward, and there is a code in front of you. Okay, so here what I have done, that means you are available with a 3D array. Okay, that means you can see there are three brackets. Okay, one, 1, 2, and 3. Okay, three brackets are there, and you are available with elements 1, comma 2, comma 3. Okay, and if I would say that what element is present at the index position 0, 0, 2. Okay, so the element which is present at the index position 0, 0, 2 will be as 0 is the outer dimension and 0 is your row. Okay, this particular row. Okay, and we are available with three columns. Okay, so element 1 is present at column number 0, 2 at column number 1, and 3 at column number 2. Okay, so 0, 0, 2 will obviously going to represent 3. All right, if you are available with this kind of array, okay, that means this is what, again a 3D. This is again a 3D, and the point is you are available with how you can represent this particular thing, since we are available with the three square brackets, so it's a 3D thing. And if I would say this is row number 0, this is row number 1, and the question asks to you what is the element present at 0, 0, 2. Okay, so 0, obviously this whole represents a 0, 0th index. Okay, and then 0 is again the row, so this is the 0th row. Okay, and 2, obviously element 3 is present here. And if I would say 0, 1, 1, so obviously the complete structure is having a 0 axis. Okay, and then 1, that means I'm talking about this 1th row, and this 1 means okay, element present here at the 1th index position. Okay, so you should be understanding, sir, this is column, this will always represent column, this will represent your row, and this present the outer axis. All right, so with the help of it, we can find that what value is present. All right, fine. So we have seen so many codes related to this, and we have found that what elements are present. For example, here if I would say you have created again a 3D array, 3D numpy array. Okay, so in 3D numpy array, after printing print arr, I found that okay, this is the structure. And if someone asks to you what is the value present at 1, 1, 2, 1, 1, 2, okay, see, the point here is this is 0th index and this is 1th index. You have been question asked what is the value present at 1. Okay, so 1, that means I need to work out here 1. Then it has been asked 1. Okay, that means this is 0th row and this is 1th row. Okay, so you need to go here. This is the one. Okay, and then you have been asked for 2. That means second column. So here's the second column. Okay, that means this is 0th column, this is 1th column, and this is second column. So the value present here is 12. So you need to understand you need to understand uh, that how we are available with the axis, how the arrangement has been done, then accordingly you can find the element easily. Now, as we have seen that the positive index start from left to right, the negative index will start from right to left. Okay, also in case of positive indexing we are available with the zeroth index. Okay, that means we work here from zeroth index. We have seen in case of list also. Okay, but in case of negative indexing the things start from here in a minus. Okay, same approach what we have learned in the case of list. Okay, so if I would say what is the element present at minus 1, arr minus 1, so obviously the element present at arr minus 1 is 5, minus 2 4, minus 3 3, minus 4 2, minus 5 is 1. Okay, this is how the elements are present. All right. Now, in the next case, if I would say your array is this thing again 1, 2, 3, 4, 5, 5 elements are here. And if I would say ARR 0, comma minus 2, ARR 0, comma minus 2. Okay, so 0, comma minus 2, what it will be? What it will be? This is minus 1, this is minus 2. Okay, so the result which you are getting here is 4. The result which has been found here is 4. Okay, so the point is, are we performing any slicing here, or it's something else we are doing? Is something else we are doing? We need to understand this point. Okay, previously in general I asked arr minus 1, it returned me 5. If in general again I would say I am having your arr minus 2. Okay, so it should return me 4. And here again I asked arr 0 comma minus 2. So 0 comma minus 2, what it gave to me? It gave to me 4. That means, is it interpreting the things just like same as arr minus 2, or what is the significance of using 0 here? What's happening? Let us proceed ahead with another code. Okay, and then we will have a discussion over it. For example, I am available with this 2D array. Here is your 2D array. And I am saying print arr 0 minus 1, 0 minus 1. So I understood, okay, 0 minus 1, that means this 0 is saying okay, you should be in a 0th row, and the last element which is present at the 0th row, you kindly print it. So the last element which is present in the 0th row is 5, so I printed 5 here. Now if I would say, let me copy this particular code. Okay, and just do a modification in this code by this thing, arr 1 minus 1, then what will be the output? The output is 10. Okay, now I understood, sir. This is 0th row, so the last element present in the 0th row was 5. This is 1th row, so the last element present in the 1th row is 10. Okay, so this thing 1, 0, these are representing the row in which row you are trying to access the element. Similarly here also, if I would say arr 0 minus 2, so obviously it's gonna print me 4. Whether I will say arr minus 2 or whether I will say arr 0 minus 2, the point is here, um, you are available with the 2D array. Okay, but the structure of this array is something like that, you are having only this row. Okay, if there is a different scenario, for example, if I would have changed this thing, this particular list of elements into this particular format, so obviously you are having two rows, then this is also a row, this will also a row. But at, at general right now, here I am available with only one row, so if I say 0 minus 2, it will return 4, or if I would say arr minus 2 only, then also it will return 4 to me. Okay, so understand, I'm not talking about any slicing here. Okay, this is separated by comma. The elements are separated by comma. 0 comma minus 2. So this 0 represents the row, and -2 represent the element which is present in the array. All right. So here we did perform changes in the code also, and after doing the practical, we understood this concept. Now, for example, I am available with the list 6, 7, 8, 9, 10, and I'm preparing an array using this list. Okay, so this will be your array. Okay, I printed it. And I said print ARR greater than 7. Print ARR greater than 7. So, this kind of comparison also you can do in case of NumPy. Okay, if you are saying ARR greater than 7, so this 7 will be compared with each and every element present in the array. Okay, so now what will happen? ARR greater than 7. Okay, 6 greater than 7, false. The result will be Boolean. Okay, 7 greater than 7, false. Then 8 greater than 7, yeah, it's true. 8 is greater than 7, it's true. 9 greater than 7, true. 10 greater than 7, true. So here are the results. So you will get a list of this Boolean values when you are going to compare the array. Okay, doing some greater than, smaller than, whatever you want to do. This kind of task has also been possible here. Directly it is possible. That means you are comparing an array with a number, and all the Boolean values you are going to get as a result. Okay, if I put a change here, okay, there are some more modifications you can do, and this is really interesting. You have created a array with these elements. Okay, you got a list, you're given as a list in the array, and you have printed this array. Now, if I would say print ARR greater than 7, you have already seen this example above. Okay, that means it's gonna return you the Boolean values, true, false. If I would say ARR greater than 7, that means return those values which are greater than 7. Understand the meaning of this particular line. I need to return those values which are greater than 7. I'm not talking about the Boolean structure. Okay, so it will return me 8, 9, and 10. 8, 9, 10. These three values will be returned here. They are greater than 7. Okay, so this task can also be performed using just simple operations on NumPy. Okay, now next thing. If I am available with np.arrange 20, okay, so nums equal to np.arrange 20, that means you are taking the elements from 0 to 19, you very well know. Okay, because it's a range. I printed those values also here. Print nums. I printed the values from 0 to 19. Okay, then I performed some operation. Odd number, odd underscore num equal to nums. Inside a nums, I am taking num percentage 2 equal to 1. Num percentage 2 equal to 1. Okay, you can insert one more statement here in between as we did above for the Boolean operations. For example, if I would say print this thing, num percentage 2 equal to 1. Okay, as we did here, na, array greater than 7. Similarly, just put it here, num percentage 2 equal to 1. Okay, and then here what we are doing, we are assigning a variable odd number, and we are saying that return those numbers in this nums who are odd, because num percentage 2 equal to 1, that means remainder I'm getting is 1, so obviously odd numbers are going to be returned here. All right, so here you are going to return the odd numbers, assign all of them to the odd numbers, and print them. Okay, so let me run this code, and I found that this is what the Boolean operation which we did above also with ARR greater than 7. Same thing I have performed here also. So you understand that in print also, in print statement, just simply in a print statement, we are performing nums percentage 2 equal to 1. In print statement we are doing. Okay, and then outside it, I am taking, okay, whatever be the numbers which are giving remainder 1, put them into index. This is the index. Okay, and I am returning the value which are present at that particular index values. Okay, like this, and these values are 1, 3, 5, 7, 9 up to 19. These are the odd numbers. And here I performed division of number by 2, and remainder I got 1, then it is written as true, else it returned false. So you can see that true, false, all complete thing are present here. Okay, so again, it's just like an example as we did above. Here I performed how to print the even and the odd numbers using Numpy. Okay, previously we did lot of codes based upon this using loops and all if and else conditions and all these things. But right now we are doing this thing with the Numpy. Now you can perform iteration over the numpy array also. For that it's quite easy. You create a numpy array 1 2 3. Okay, here is a numpy array, and you have performed the iteration over it. That means for x in arr print x. Okay, as simple as you did in the previous topics also, the same here for x in arr, and then print x. Okay, so here the values are 1 2 3. And it's not like that, because in previously we did worked upon the 1D thing only. Here in the next case you are available with a 2D array. Okay, this is a 2D array. And if you performed for a loop here also, for x in arr print x. Okay, so it will print all the elements one by one. That means first it will go through this particular row, and then it will go through this particular row. Okay, and it will going to print you these elements. All right. So if I'm available with only 1D, okay, it will print you like this. And if I'm available with a 2D, it will print you like this. Okay. Now, if you think, sir, is there any possibility can you print these elements in the same structure as we did in 1D? Yes. Now you need to use Y also, one more variable. How? Because it is a 2D, obviously we require two loops. Okay, because it is a 2D structure, definitely we require two loops to perform the operation. So I am saying this is a 2D array. Okay, and I am saying for x in arr. Okay, for x in arr, so I pick this particular this first position. Okay, 0 0. Okay, it's 1. Then 0 1, it's 2. Then 0 2, it's 3. Okay, then I switched to row number second. Okay, then 1 0 4, 1 1 5, then 1 2 6. Okay, so this is how the elements are printed. Okay, so I took for x in arr and for y in x, then print y. Okay, so what does this x is representing right now here? What x this x is representing? This x is actually your row. X is row. So when I say for x in arr, I am talking about the row number 1, first row. And here for y in x, that means every element which is present in this row. Okay, so it first printed 1, then 2, then 3. Okay, that means all 3 columns. That means I am talking about, if I say x is a row, then what should be y? What should be y? I said every element present in this row. So this is column number 1, column number 2, column number 3. This is how the elements are printed. Okay, now this is the operation based upon 2D. What will happen if you are available with the 3D structure? So this is 3D. This is a 3D matrix. Okay, and then if I apply loop over it, for x in arr print x, apply loop over, simple loop, just for x in arr print x. So it will print me this 1 2 3 4 5 6, then it will print me 7 8 9 10 11 12. Now if you want to print all the elements one by one, since it is a 3D matrix, since it is a you have created an array 3D. Okay, so you need to use x also, y also, z also, and it's quite simple, and the logic is very well understood to you. Okay, in the above example, when there was 2D, you said for x in arr, y in x. If you are available with the three things 3D, Then you will say for x in ARR, for y in x, and for z in y. Then you are going to print a z. Okay, that means go inside each and every. Okay, so the thing is x is your outer, then y is its inner, then z is inside that. Okay, so if I would say, because x will represent the outer loop, so if I would say z is this particular row, so it will print 1, then 2, then 3, one by one. Then it will go to the next 1, 4, then 5, then 6, next row. Okay, so this z will be representing the columns, and y will be representing the row, and z will be representing the outer axis. Okay, and here all the elements are printed one by one. So previously it was just a general iteration, x for x in ARR, and this is just a general iteration. And here also there is a iteration, but here we are printing each and every element. There is a change. So how much flexibility you are available with in case of Numpy? Okay, now see, there is one more method that is called as end iterations. Before that, I want to use something, a different logic. You are available with arrange here. Okay, that means range from this to this. You are available with arrange. Can we do a code using arrange also? Is there any possibility? For example, if I take a code here, okay, and I paste it here, I don't want to use x in ARR. I want to use arrange here. Okay, can anyone unmute and let me know that, sir, how arrange can be used? Because we have used range also. We have used range also previously. Okay, in when we are going to print there are two ways to print the elements in the list. One is by just simply for I in list, and there is one more thing for I in range. Then we are going to do something else. I want a help from you guys. Anyone can tell me, sir, how to use a range here? What is the possibility? If I will take for x in a range,
We will
yeah, say please. Range. How much I'm going to take? A range.
we will either starting value,
Okay,
the
right.
ending value, and if
Start.
we want step.
Okay, starting value, ending value, 0 comma 3. Is that the case? Arrange 0 comma 3, because I'm available with the three elements here. So the index will be 0, 1, and 2. Okay, and what I need to write here in case of x? Should I need to write here x? Is that the case? Because we need to see, arrange will be the index now.
Yes, sir.
Okay, let me run this code. It gave me error. Arrange is not defined. That's it. So should I need to write np dot arrange? Because previously we have used the np dot arrange, sorry, np dot arrange. Because arrange is a method of Numpy, and the range which we have used in the previous classes for the list, so range is that method, but arrange is a method of Numpy. So you can't use arrange without Numpy. So np dot arrange, then give 0 to 3, and what you got here, you have printed every element using arrange one by one. That means the point is clear. And is there any possibility, if we are available with the 2D stuff, we are available with the 2D stuff, okay, and can we use arrange there also? Now let us do some experiment over this thing also. Okay, I am available with the 2D array. How can we use arrange here? What is the possibility of using arrange? What should I write? You know that, sir, there is 2D, it's a 2D actually. Okay, so this is outer axis, and this is this is 0, and this is 1th. If I print this particular array, if I print this array from my end, okay, so the result will be like this. This is the result. And if I traced for using for loop, the result, it give me like this. Any possibility that you can use arrange here? For example, arrange something, np dot arrange, and what should I write? What should I write? 0 to 3. If I say 0
limit.
comma 3, hmm?
We can
Yeah,
hide this.
yeah, 0 to 3. If I say, let's see what happens. Let's see what error it going to give me. ARRX. Remember, this is 0, okay, and this is 1th row. And you are taking only 0 comma 3. Okay, and let me print it. That means index 2 is out of bound with the x is 0, size 2. Okay, there is some issue with the range here. You can't use it just simply. Okay, so definitely there will be an issue. Index error, index
Sir,
2 out of
we
bound.
will
Yeah,
not give index now, sir.
yeah, we,
We'll give that no, sir.
how to?
Like if we give 10
Hmm.
to 20, it will print the number between 10 to 20,
Hmm, hmm.
not the index values, no, sir.
See, if you say 1 to 20, no, so obviously this is an index position. If you just simply say print np dot arrange, if you in a simple terms you say print np dot arrange, if you say 20, so what you are saying right now, sir, it will print the elements from 0 to 19. Yeah, but I'm going to use these elements as an index positions. That is what my thought is. So in the previous lectures also, when we were working with a list, okay, or tuple whatsoever, which are based upon the indexing. Okay, so there was a range function. Okay, and in range function we are using whatever the values present in the range, because things, what things happen, it starts with 0. If I take a range 20 or range 20, it starts from 0, and we know that here the things work on the basis of indexing. Okay, so I'm going to take these 0 1 2 3 as an index position. So whatever the values which are written here, these are the form of an indexes. I can use them, I can put them in the form of an index, and I can print the values. Okay, so that's what my thought is. So the point is, sir, I'm getting an issue. I'm getting an issue. So can't we print the shape of ARR initially? What is the shape of it? Print shape. It's 2 3. This is the shape of your array. That means 2 rows and the 3 columns. Now we got stuck. Sir, how to use np.arrange with 2 rows and the 3 columns, sir? Okay, so is there any possibility, sir, I need to use one more range here? That means for x in range this thing. And should I need to use one more arrange? Copy and paste it here. For y in MP range 0 to 3. Or I need to take 1 to 3. What should be there? Because the point is they are having 2 rows. So I need to trace the row number 1. Then I need to trace row number 2. This is what I need to do. If I would say 0 comma 3, range 0 comma 3, so it gave me a answer out of bound. Okay, so what, because when you are going to print the array elements in 2D, so you need to obviously apply two loops. And we did here also. We did here about, if I would say, in case of 2D, in case of 2D, you applied for x in ARR, for y in x, you did this stuff. Okay, so similarly, we should be doing something here. We have to do something here. But what should be done? Because arrange will give you a series, index. Okay, if I would say 0 comma 3, it will give me 0th, 1th and 2nd. This index will given. And for y in what? Why should I need to take x here? If x represents row, so I need to give it here like this. 2. np dot arrange 2. That means row number 0, row number 1. And that particular row will come here. The first row will be come here. Okay, the value of x will be 0. And what should I need to print here? I am saying ARR x. It should be ARR y. Okay, let me run the code. What happened? Again, it say there is some issue. Index 2 out of bound with the range. Or what should be here? Is it x comma y? Let me run the code. Now understand what I did. I did everything practical in front of you. This code is nowhere available. You can search on whole internet. Nowhere available this kind of code. Neither any example given in any of the book, any article, nothing. I just thought, I just put a thought process. Okay, and what I thought is, sir, if I can do the stuff using this kind of operation, so can I do a stuff related to arrange also? Because arrange is something, and what logic I used in front of you. Understand what logic I used. See, x, if I would say, I got an idea. What idea I got from here? That, sir, the idea is, if x is representing the row, y is representing the column. Okay, so why shouldn't I say x in np dot arrange 2? Because I know that this is a 2D matrix. This is 2D. Okay, so I am having two rows here. So this will be one row and this will be second row. So what I took is np dot arrange 2. That means there will be 0th row and there will be 1th row. Okay, I got. Then once I get row, and I am going to print every element which is present in those specific rows. Okay, so here I took x, np dot arrange x. That means first my loop will work for row number 0, then my loop will work for row number 1. Okay, so initially when my loop is working for row number 0, I said okay, 0 and take 3. 0 to 3 means it will take 0 0 0 1 0 2, because 3 is obviously excluded. And here I am printing the element which is present at that particular index position. That's what I told right now. 0 0 0 1 and 0 2. So element are 1 2 and 3. But something happened here. Can you see there is no 4 available? Why it happened? What could be the logic? There is no 4 available. I'm getting 1 2 3 5 6. Why there is no 4 here? I'm expected that, sir, if you are saying 0 0, it will be 1, 0 1, it will be 2, then 0 0 2, it will be 3, then 1 is 0. This should be 1 is 0 now. The next element should be 1 0, because now the value of x will be 1. The value of x will be 1. In the next case, when this loop is over, is over, the value of x should be 1. So 1 comma 3, that means again it should start from 0. 1 is 0, it needs to be taken. So 1 0 is 4, but here it haven't printed 1 0. It printed 1 1 and a 1 2. Those values are 5 and 6. So you need to explore more how this thing happened. But what I created a logic, and right now I did a code in front of you that this is something happening which is I'm expecting. So I found first the shape, and then I put the values here and created using arrange. So this stuff can be used by can be done by in this format also, and it can be done with this thing also. But you need to find the reason why 4 is not printed here. It printed all other values, but 4 is not printed. But as per my logic, the logic which we have used, its index position should also be covered here. All right, fine. Okay, any other doubt, please let me know. Some girl asked the question, sir, arrange is this thing. Any other doubt, please let me know. Do you want to say something, ask something, please? Any doubt? Ramya?
No, sir. Only that doubt I was thinking about, sir. Why 4 is not printed?
Okay, so you need to think over it. Why this thing, why happened? And the logic is considering rows and the columns. So you need to check out the logic also. And my logic is what I thought is somehow what it's correct. But only I have a question. Why 4 is not printed here? Everything else is printed. As per the index, 4 should also be printed. Okay, so you need to look over it. And this code is nowhere available, please. This is something which has been prepared here only while discussion. Now you are available with one more method, that is iter, and that means iteration. Okay, so if I'm available with this thing array, this is a 3D array. Okay, and if I perform x dot np dot nd iter array, so it will print me all the elements one by one. So previously we are cracking the problem. Okay, we are using x in arr, y in x, z in y. Okay, that means loop inside a loop, nested loop, so that's creating an issue. So you will say, sir, kindly any simple terms, any simple you can perform. So already there is a predefined method available in the numpy, that is called as np.nditer. So if we just do right, use this particular thing and given our array inside it, it will print each and every element one by one. That's it. So nditer. Okay, similarly here in this particular case I've used nditer again. So I'm available with the array 1 2 3, and I'm using for x in nditer arr flags equal to buffered and data type is s. What does this mean? Flag equal to buffered and data types is equal to s. So in this particular case, the flags argument is set to be buffered, which means that the elements of the array will be processed as a buffer. Okay, uh, that means they will be in, which means that the elements of the array will be processed in a form of a buffer is something, that means it's something in a stock, additional stock buffer. We keep the things in buffer now, extra stock. So it's not going to process it in a core way, it's going to process it in a buffer way. Okay, and then the processing will also be done according to s. The data type I took s, which means that elements will be processed as a string format. Okay, so I am keeping the elements in the buffer. That means there is a, in the memory I'm going to take, there's some space, that's a buffer space. So I'm going to put these elements into the buffer and process them in the form of a string. Okay, and you can check out the results what you are getting. B1 B1 B2 B3, these are not simply 1 2 3. Previously it was simply 1 2 3, but right now we are processing them in the form of a buffer. So definitely the results which you are going to get is in the form of a strings. So here it is, string, bytes. Okay, B1 B2 and B3. Okay, so this is another code, that means different from which you have seen above. In the next code, again I have made some twist, again using nd iterations. And here you are available with a 2D array. And what I did, for x in np dot nd iteration arr 1 colon 1 colon 1 colon means 1 colon means this is slicing. What does this 1 colon means?
Start from the one index and go on till the end.
Okay, see, one index you are talking. So so the point is, which row I'm going to cover here? One, you're saying, sir, 1 colon, that means to start from one index. Which colon, which column, which row I'm going to cover here?
Second row.
Second row. Okay, fine. We are going to work upon this second row, and then we are available with colon colon 2. What does this mean? colon colon 2.
So
From starting to end,
Okay.
skip 2 steps and print the final value.
Okay, from starting to end and skips two values. Okay, so iteration here, we are going to extract all the rows. That means from the second row, that is index 1, because index 1 is your row number 2, and all the columns with the even index. Remember, all the columns with even index. So the point which you said, sir, skipping, that means I am to work upon each and every element which is present in the row number 1, but I am going to consider columns with even index. That is index number. What will be the index positions? Index position. This is your 0, and this is your second index. Even index elements I need to print. So the even index elements are 5 and 7, and 6 and okay, 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 okay. Wait a minute. Wait a minute. Again, there was a twist happened. If I do talk about even index position, but the even index positions are having 6 and 8. 6 and 8 are the even index positions. So I guess we are doing something else. And what the answer I found it, sir, you are going to take not only even not index even index positions. You are going to skip the two values. That is what we are going to do. And yes, she is correct. Not even indexing. We are taking this value, first value, then with a gap of 2, we are printing this value. So that means we are taking the odd index positions, not even index positions. Okay, so row, this is your um, row number 1. So this is your row 0, and this is your row 1. And here we are tracing each and every element with a gap of 2. And we have seen this stuff, colon colon 2. That means consider everything with a gap of 2. So your elements are 5 and 7. If I don't say gap of 2, for example, copy and paste it here. Don't say any gap of 2 here. Then what does it going to print me? Does it print each and every element which is present here? 5, 6, 7, 8. Okay, let's check. 5, 6, 7, 8. All the elements are printed. No gap is there. Okay, and if I say copy, because actually this is slicing method. Copy and paste this code here, and if I'm going to remove this one also, that means consider all the rows, all the columns. Okay, and run this code. Everything will be printed. 1, 2, 3, 4 up to 8. Everything will be printed. Okay, one more stuff. If I copy this code and paste it here, and don't use this colon here. Don't use this colon. And let me check what will happen. Again, everything will be printed. Okay, and copy and just use this code again and do some another experiment. Take 0 here. 0. And if I take 2 here, 0 colon 2. So what does this mean? 0 colon 2. Remember one thing. Remember, this is for rows,
it
and
is
after
out of
comma this is
index.
for column. Yeah, 0 colon 2. Yeah, it will be, yeah,
Out
out of
of
bounds. You are saying, sir, it will be out
no,
of bound. We are available with 2 rows only, and you are putting, sir, outer limit as 2. 0 colon 2. Let me run this code. Where it is out of bound? No, I am excluding this limit, outer. See, you're by writing 2,
but
that means it's,
two is
yeah,
out of.
2 is
But there are only
2
zero
rows.
position and one position, no,
There
sir.
are only 0 position and 1
Then
position.
you gave two, no, sir.
2 na I gave na. There are 2 rows basically. There are 2 rows. So before comma this stands for the rows, and after comma this stands for the column. Okay, and outer limit is always excluded. So 0 comma colon 2 means 0 row and 1th row. And if I would say, if still you are having in doubt, let me copy paste and put this code here. Okay, and if I'm going to use 1, if I'm going to use 1, what it will print? Let's check. It will print only 1, 2, 3, 4. That means all the elements which are present in the 0th row. Understand what I'm saying? Yeah, the girl who asked it out, please. What you understood from here? 0 colon 1 and 0 colon 2.
It will consider only first row
Yeah.
four elements.
Yes, and if I say 0 colon 2, then it will consider first row also and second row also. So it is mandatory for all the students to understand. See here it's divided into two parts. This is for row and this is for column. Remember. And if I would say colon, let me copy this code and paste it here again. And if I want to do slicing in, because right now I'm dealing with the slicing in numpy array, if I say 0 comma 1 and if I put it here 2 comma 4, what answer it will give me? 0 colon 1, 2 comma 4, 2 colon 4. What will be the result? What will be the result? What elements it will print me? Ramya, Rishmita, what answer, what result it's going to print me?
2 and 3.
What 2 and, are you
3.
sure 2 and 3 or 3 or 4?
2 and 3.
Okay, 2 and 3. Okay, let me log this answer and let me get the answer, that is 3 and 4. And you see, you know that why 3 and 4 came, but just you hurriedly told that 2 4, that means this is second index beta and this is third index, and I'm saying now 4, that means I need to exclude 4. So what is see, this is 0th index, this is 1th index, this is second index, and this is third index. So I'm taking na 2 colon 4 na
Yes,
second
sir.
index and the third index. That's why 3 and 4. And considering 0th row only. So I know that you guys know the answer, but just really you came into the conclusion. Okay, the result is 2 and 3. Anyways, no worries. Okay, so now the next code. I hope ND iter. Now this is a slicing which we are doing with the help of ND iterations. Okay, now next code. ND enumerate. Have you heard about this method, ND enumerate? See, enumeration we have seen previously in codes when we are using this list also. Enumeration, that means we are having index also, we are printing its value also. Enumerations. Have you done this thing, this stuff in your Numpy practice? Have you done whatever the codes which we are doing? Have you done all these codes in Numpy?
Awesome.
Okay, so here,
Some of
Some
them
of them,
only,
sir.
sir.
okay, some of them you did. Okay, so here right now we are available with ND enumerate, enumeration. Okay, so what is this ND enumerate is going to work for you? Enumeration. See, uh, this function, as I told, that I am going to print the index position also, and I am also want to show you that what element is present at that particular index position also. Okay, so for that reason I am going to use ND enumeration. Okay, so here this is your array 1 2 3 1D array, and I'm saying for idx comma x, for idx comma x, that means print the index position also and print the value also of that particular element. Okay, so np dot enumerate arr idx x. So at 0th index position 1 is present, 1th index position 2 is present, second index position 3 is present, that's it. And if you take 2D array, this is 2D array, and again use the same code for idx comma x and np dot enumerate arr, then it will going to print you this thing 0 0 1 0 1 2 and all these. You very well know, sir, index position also and values also, not a big deal. So just use nd enumerate method in numpy. All right, again if you are having 3D array, the method is all same. Okay, so 0 0 0th index I am available with 1, then 0 0 1 I am available with 2, and 0 0 2 I am available with 3. Okay, so the logic is all same, and using as ND enumerate is very much easy for idx in x, and it's up to you. Okay, now sir, can we add arrays? For example, if I am available with two arrays, array A and array B, and these two arrays are 2D array. Okay, this is the 2D array. Okay, and this is also a 2D array, and we need to perform addition of it. So addition is quite simple, as we do by our adding to two numbers. How? how the addition is performed here. So this is 1 na? First element of array 1, array A. So this will be added to 7. 1 plus 7, the result is 8. Then 2 plus 8, the result is 10. And 3 plus 9, the result is 12. So, row by row addition. Every element it is present in this particular row will be added to this particular row elements. And again, this row will be added to this row. Row by row addition will be there. And you can see the answer. 8, 10, 12, and 14, 16, and 18. This is what the result you have got. Okay, so row by row addition has been performed here. If I would say again, here is your code. Just previously I took some 2D.
Sir,
Yeah, please say. Just ask the question.
the
Yeah, see the
then will there
see see addition see
addition
addition see see the addition here. You can say the index positions, I would say. This is 0th index position, so 0 0 is added with 0 0, and 0 1 is added with 0 1, and so on. Okay, and we have checked that when we were iterating over any array using for loop, when we were performing the iteration, okay, and we check that the elements which are printed are according to the row only, because if I do iterate over this particular array A, the elements will be 1 2 3 4 5 6. It will not be like that 1 4 2 5 3 6. No, it consider first, it will complete the first row and then it will go to the second row. So accordingly, if you need to perform the addition, it's going to work upon row by row. Okay, and this is 0 0 index, this is also 0 0, add these two. Okay, and if you want to perform addition in a different terms, for example, if you want to print A, and it's up to your choice, sir, what kind of addition you want to say. You want to do, sir, 0 comma 1, sorry, I write 1 comma, okay, 1 comma 2 plus b p. You will say, sir, I need to add 0 comma 1. So what this means, this is row number 1. Okay, this is row number 1 and this is 2, column number 2. Okay, so what element which is present at 1 2? So the element which is present at 1 2 is, I guess, 6. Okay, and the element which is present at b01, that means first row, this is first row, and 1, that means second column, 8. So what will be the answer? Let me run this code. It gave me A is not defined. Okay, I need to run this code first. First running this code and now running this code. Answer is 14. Okay, that means the point is at 1 2, the element present is 1 2. That means this is the 1th row, and 2, that means second column. 6 is present, and at b01, the element which is present, that means this is the 0th row, and this is 1th column. Okay, 8. So 6 plus 8 is 14. This is how the result I got. But if you want to do A plus a B, so it will be done according to its index by index addition. Now ask the question. Still, if you are having any doubt, please let me know.
no doubt, sir.
Okay, so this is how addition is performed. In the next case, again, this is a simple addition. Thus, I took 2 3 and 4 2. So obviously the result is 2 plus 4 6, and 3 plus 2 is 5. So I guess there is nothing important here. Okay, and again, this is 2D addition. So but the point is, there is some change. If I will take plus sign, x plus y, it's going to give me addition. There is already np.add method available in numpy. So if you do a plus b, or either if you do np.add a comma b, it will perform the addition. Already add method available in numpy. So I told now all numerical computations. So numpy is already having predefined methods. So it can perform the numerical computation easily from its end. Okay, so add, it will give you the same result. Subtraction, same thing. Okay, again index by index subtraction. 1 minus 7 minus 6, 2 minus 8 minus 6, 3 minus 9 minus 6. So this is your first row. Then 4 minus 10, 5 minus 11, 6 minus 12, second row. And if you want to, you say, sir, this is subtraction. No, let me copy this code. Okay, or let me copy this code and put subtraction. So minus will going to give you the subtraction. If I would say, if I would take sub, sir, now is it possible to perform subtraction? Is there any subtraction method available in Numpy? It gave error. Module Numpy has no module subtraction sub. So do it have any other thing? Subtract, np dot subtract. Yeah. So when you are performing some task, na, you say, sir, you are teaching. You know each and you remember everything. It's not talking about. It's not a matter of remembrance. It's a matter of practice. Remembering each and everything is not been easy task. Okay, but the point is, if I do practice, I can drop a logic here. Okay, if sub is not there, okay, subtract might be here. It's a matter of practice. So np dot subtract will gonna subtract every element which is present in a and b, and you can see the result. So add is for add and subtract is for subtraction. Okay, and multiply a into b. So here is your multiplication again, one by one element multiplication. Okay, you can perform. Here also is there. Here already there was a comment, but actually I haven't seen the comment. Okay, and I did the logic from my end. Here if you need to use multiply, then there is a method available, np dot multiply. So it will multiply each and every element present here. So the multiplication will again somehow it's the same thing. 1 into 7, 2 into 8, 3 into 9, then 4 into 10, 5 into 11, and 6 into 12. Multiplication will also be like this only. Okay, now if you want to perform the division, so I guess division will also be the same, 1 by 7, 2 by 8, and so on. And you can use np dot divide method also to perform this task. All right, fine. Let us consider some another code. I am available with I am means I am creating different arrays, different types of arrays. First, my first array is names. Then I'm taking np dot array. I'm taking three name. Okay, then I'm taking the heights, np dot array. I'm taking 1.5, 1.78, 1.6. These three floating point value height. No, I'm taking these floating point values, and I'm taking weights as in this particular format: 60, 65, 46, 40, 15, anything. So I created three arrays: names, heights, and weights. Then I'm going to calculate BMI, that is body mass index. BMI stands for the body mass index. And the formula for the body mass index is weight divided by height ka square. This is the formula for body mass index. All right. And then what I'm going to do is, I have calculated this value, BMI, that is weights by heights ka square. Okay, that means I'm going to consider 65 divided by 1.5 ka square. I'm going to get some value. Then I'm going to divide 46 by 1.78, 1.78 ka square. Then I'm having 59 divided by 1.6 ka square. So this is a formula of BMI. I think I should have to print BMI also here. BMI. Let us print this thing also. And then I'm saying, okay, I printed here. No need to again print. I printed here BMI. Then I'm saying, in the names, if BMI is greater than 25, that is overweight. If BMI is less than 1.85, just find the values. Just find the values where BMI is less than 1.85 in the names. Then it will be underweight. And if BMI is this and between this, then you are going to say it's a healthy person. So if I do run the code, it's already executed. You got the answer. But you know what you did here? What you did here? Here, you created a variable BMI in which you perform this operation, weights divided by height square. That means you are dividing this thing by this thing, storing the value, then this thing and this thing, and this particular value and this particular value. And then you said BMI, you got the value, na BMI. If BMI is greater than 25, so it will check, okay, whose BMI is greater than 25? Okay, just check in the names. Just check in the names. So here I printed BMI. You can see this is the BMI, body mass index. So the for the first one is 28, second one it's 14.51, and then the third one it is 23. This is your BMI I have printed here after the calculation. So this will again an array. You will say, sir, performing operation over array will give you array. So this is again an array. BMI. Though you will say, sir, you haven't declared BMI as array, sir. You just use a simple variable declaration and you have used a formula, weights by height and chi square, and you have just used a simple formula where this BMI is not declared as an array, sir. Array is name, height, and weight. But if you're going to perform operation over array, the results will be stored in the form of an array. Here is the result, BMI. And then you checked, okay, then you checked with BMI greater than 25. Check in a names, I'm going to check it. So this is the result which I got. And the third one is very interesting. You can apply the condition. This is a mix of condition. Previously I was just using simple condition. Now I'm used BMI greater than this and BMI less than 25 equal to 25. The result is this. Okay, so this is how you can interpret the results. In the next code, dot product. See, multiply and dot is having a difference. Here I'm performing dot product. Okay, so how this dot product is going to perform? If I say multiply these two, so you will again get what you are going to get. Previously when you perform the multiplication, you got an array, during multiplication. Here also, if you do multiply x and y, you will get an array. 2 fours are 8 and 3 twos are 6. So 8 and 6, you will get a result. For example, if I say print np dot multiply, okay, and if we put it here x comma y, so we'll get a array. Okay, that is a 1D matrix. That is 2 2 4, that is 8 and 6. Okay, multiply by these two. 2 fours are 8 and 3 twos are 6. This is what result you got. But what is dot product? I'm not talking about this.
Matrix multi
Yeah, what it is?
matrix multiplication, sir.
Okay, matrix multiplication. Dot product is actually matrix multiplication. Okay, so how I'm going to multiply this matrix? That means, are you saying, sir, 2 multiply by 4 is 8, 3 multiply by 2 is 6, and then, sir, we are going to add 6, 8 plus 6, so the result is getting as 14. So she is absolutely right. Matrix multiplication we are taking, and you should be aware how the matrix multiply, because there is a rule in matrix multiplication. Okay, what is the rule? Let me check out with the dashboard. Let me share you a dashboard, and then we will understand what is the rule for your matrix multiplication. Okay, that means let me have a whiteboard. Okay, then we'll check how this multiplication is going to work upon. So if I need to check out for the rule for the matrix multiplication, if I'm having, for example, 2 3 4 5, and I'm available with 6 7 8 9. Okay, this is 2 cross 2 matrix, you very well know, and this is also 2 cross 2 matrix, you know it. So what is the rule for the matrix multiplication? Can anybody tell me rule for the multiplication?
rows of first matrix should be equal to the columns of the second matrix.
Okay, row of first matrix should be equal to the columns of second matrix. If I prepare a pair of these two, is it okay? Is it okay if I pair this thing? This should be same. That means columns of first matrix should be equal to the rows of second matrix. Is this also be okay? Or I'm specific that rows
Yes,
of
sir.
first. Okay, so they should be the same. For example, now if I'm going to take 2, 3, 4, 5, done. And if I'm going to take, this is 2 cross 2, and if I'm going to take 6, 7, 8, 9, 10, sorry, 10, 11. So this is 3 cross 2. This is 3 cross 2. Is it correct or not? This is 2 cross 3. This is 3 cross 2 matrix. Can we have a multiplication of these two or not? And no, I got an answer previously that the rows of first should be equal to the column of second. This is the result I got the answer primary. And but I said from my side that columns of first should be equal to the rows of second. This is what I told, and this is the answer which I got previously. Now please tell me, can we have a multiplication of these two or not? Tell me, multiplication. And how we multiply? How we multiply matrix? Should I have to take like this, 2 multiply by 6? Then I need to take 3
We can't do
multiply by 8.
multiplication, sir.
Yeah, we can't do multiplication. Wrong. So, but I got the answer now previously. Sir, number of rows of first should be equal to number of columns for the second. And now, if I use my technique, what? Number of columns of first. So let me rub this thing. Let me rub this. Or let me use another slide. Okay. My technique was like this: 2, 3, 4, 5, 6, 7. So this is 3 cross 2. And the next will be 1, 2, 3, 4, 5, 6. So this is 2 cross 3. And I told, okay, column of this should be equal to row of this. Can it be multiplied or not? Can it be multiplied? 2 should be multiplied by 1, 3 should be multiplied by 4. Done. Is it or not?
Yes, sir.
Okay, and then next 4 should be multiplied by whom? By whom 4 should be multiplied next? We need to perform the operation this by this. This is how we multiply a matrix, isn't it? Then what should be next? Then again, should this be multiplied by this thing? And again, this thing should be multiplied by this thing to get the first row. Tell me. Or you have some different thing in your mind. How matrix multiplication is done?
Sir, first element should be multiplied by both elements in the
Okay, you are saying, sir, 2 should
first column, I think so.
okay, you think that 2 should be multiplied to 1 also, and 2 should be multiplied to 4 also. Is that the case you are saying? Is this what you are saying?
So, sorry, sir, I was mistaken.
Oh yeah, you are. I know that you mistaken, but it's really nice that you did a mistake, and I really like the mistakes. Okay, that means you tried for it. Okay, so I guess this element should be multiplied by this thing, and this element should be
Yes,
multiplied by this thing.
multiplied by the first column, sir.
Okay, uh, okay. Then what will happen next? Then is this again multiplied by these two, or I need to consider another elements? What should be done?
Second row and second columns.
Okay, second row and second column. Okay, so help me. Two multiple. Okay, okay. I think I had done a lot of stuff here. But the point is, then second row you are saying second row and the second, and then this thing and this thing.
Yes, sir.
Okay, so you will be having, what will be the final resultant matrix? What will be the shape of final resultant matrix? What should be the shape of final?
3 by 3.
3 by
Yeah,
3
good, good, good.
matrix.
Yeah, 3 by 3. Yes, ye wala, this thing. So rule should be this should tie up, and your final matrix will be of this into this 3 by 3. Okay, so other students, if they are still, kindly go through the multiplication, how the matrix, because here in case of Python, internal what is happening, it will not tell you. Already there are predefined methods available. So if you use dot product or any kind of product, it will directly give you result, but you will not learn what is actually happening inside. Okay, so let me reshare my coding screen. So we should be also aware of what's internally happening. Then we just remember that what the codes are. So dot product is actually your multiplication. Okay, that is matrix multiplication. Now here I am available with the 2D matrix. This is of shape 2 cross 3, and this is of shape 3 cross 2. Obviously my rule satisfied, 3 3. And then the result which I got is 58 64 139 54. That is 2 cross 2 matrix. The point is clear. Okay, so just use a dot product for that. Now again some another stuff. If NP my array is 1 2 3 4 4 4 5 4 4, and I am saying x equal to np dot where array equal to 4, that means I need to return the index positions. I need to return the index position where the value of array is 4. That means you know that at index position 3 value is 4, at index position 5 value is 4, at index position 6 value is 4. That means I'm going to return 3 5 6 index position where the value of array is 4. So where method I have used here in Numpy. If I would say where array percentage 2 equal to 0, that means remainder is equal to 0. What index positions are these? So second this is index first index position, because 2 divided by 2, the remainder is 0. Okay, so I got this thing, this thing, this thing, and this thing. So all these index position 1357, it's going to return you. So why by where we are putting a condition inside this where method, and I'm trying to print, okay, what index position in the array this actually satisfies. Okay, so here above is simple, equal to 4. Here I used the returning the index for the even values. And if it is equal to 1, obviously know that, sir, it's always going to return the index for the odd values. Okay, and you can do twist of anything. You can do any kind of twist, sir. If I going to print for, let us consider an array with -1, -3, and -8, and you can say if arr is greater than 0. If ARR, where ARR is greater than 0, so it will return the index position. Sir, 1th index position, 3rd index position, 4th index position, 5th index position, and 6th index position. That means value greater than 0. So everything is possible. It's up to you. Okay, and in normal Python, when we are dealing with the concepts of Python, we have done these codes. But here with the NumPy, you are performing this task. Okay, now next method, search sorted. Another method, np dot search sorted. Now what does this mean, search sorted? Anybody having idea what is we are doing? Sorting. Okay, sir, that means I need to sort my array, and then I need to check where this value in what on what index position this value is present. Search also, sort also. Search, sort. That means two different phenomena I am putting here in one. Previously, we have seen search. That means I need to search any element where it is present. Sort is something that means I need to organize the elements in a some sequence. That means ascending, descending, whatever. Ascending. Let us do. So here I merged search and sorting also in a Numpy. So the result is ARR 7. That means I'm searching where 7 is present in the array. So it's present at 1th index position. Okay. Now, if I just mess up with this particular value, just mess up with these values. Okay. Don't be show them in a sorted manner. 8, 6, okay, and 9. Okay. Let me run this code again. Now it's saying it's presented 3rd index position. Now, what happened? What happened? That's why, we will not go according to, okay, we are not reading theory. Okay, sir. This source order is there, sir. ARR 7 is there. These are the elements. I will get the result 1. No, you're doing practical. So it's mandatory for you to do all kind of twist with the codes. So one simple code is also in a requirement of all kind of twist. Here the result is 3. What happened? What happened? See, 7 is presented. If I do sort this thing also, 6 will come 6 will come here, 7 will be its original place, and 8 will come here, and 9 is already at original place. So search sorted. What we are doing here? Now the result is 3. So obviously there is something different happening in this particular method. So what's happening? What's happening? Tell me what's happening.
I think it will print the how much ascending
Hmm.
is that number, sir.
How much
Like
ascend?
6 value will be 0 and the 7 will be 1, 8 will be 2, 9
Okay.
will be 3.
Okay.
In that way, it will print the
And
answer.
what happened here? What happened here? There is no ascending value printed here.
Index position is taken, sir.
Index position is taken. So why you are saying, sir, there here and here ascending values are printed? Why it gave 3 here? The code is, and if I again do a twist, if I again do a twist, okay, let me paste it here and push 7 here, push 7 here, and if I take 9 here, okay, and I take 6 here, okay, and let me run this code. It's saying 0. So what's exactly happening in these particular codes? What's happening? Are sorted. How searching and sorting both are performed here? Either searching has been done first or sorting will be done. How this has been performing? What is the logic behind it? Because I need to check out both the functions are being present, search also and sort also. And and order or sequence should also be being maintained here. See, listen here, here this function search or sorted is performing the search for the position in the array where this value is present. That means I am searching for value 7. At what position value 7 is present? That means actually where it can be inserted. to maintain the sorted order of the array, where it can be inserted to maintain the sorted order of the array. And and in the previous case, that means you got the result as 1. You got the result as 1. That means it's telling that when I'm going to insert 7 at this particular index position, the order of sorting will be maintained. Here here what will happen? Here what will happen? The result got 3. Here the result I got is 3. Okay, so as per the result I got, as per the result which I got, here is 3. The function return the index, where I need to put this 7. Okay, so if I am saying 3, I'm getting 3. So that means somewhere I should be wrong, because if I sort this particular list, the result should be 6, 7 and 8. So 7 should always be at the 1th index position only. Why should you are saying that it should be present at the 3rd index position? And if I again change the sequence, then I got the result as 0. Where should be 7 be present? I don't know. But the search sorted will let you know that what will be the value, what will be uh, that particular value or the element should be inserted to maintain the order of the array in a sorted way. And it returns the index where this particular element will needs to be present. Okay, so in the first case everything is correct. Sir, I got the index position 1, and I know that 7 should be present at this position only, at index position 1. But here there was a twist. That I changed the orders. Okay, and it gave me the result as 3. So what happened? Listen, it will search where is 6 present. That means what is the minimum value? Then a 7. Sir, minimum of this value in this particular list, less than the value which is less than 7 is 6. Okay, where is 6 present, sir? 0th index position, 1 index position, 2nd index position. Okay, 6 is present as 6 in the 2nd index position. Okay, I need to insert 7 after 6. Are you getting my point or not? I need to push 7 where? Which index position? After 6, na, to main the sorting, to keep the sorting, to maintain the sorting thing. So 7 should be inserted here.
Sir,
Yeah.
then the index value
So
will
no
be
no 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 no
2.
no no no. Then see, if 7 will be inserted here, what will be its index position? See, don't bother about 7 and 8 right now. See
3,
this thing.
sir.
It will be 3. The index position will be 3, na. So I need to search for the element. Which is less than this particular value, and insert it after that particular element to maintain the sorting. So here 6 is present at the 2nd index position, and to maintain the sorting I need to insert 7 instead of 9 this position. So that's why it returned the index position 3. That means you need to insert 7 here to maintain the sorting after 6. And here what happened? 6 is already present here. So it got confused, sir. I 6 is already present at the last location. Where should I insert 7? I don't have any idea where to insert 7. And still, if you are having any issue, let me copy this code and let me just improve it. Okay, that means 5. That means okay, 5. That means 4, 2. Now, if I would say search sorted 7, where it should insert, 7.
Fourth position, sir.
Fourth position. That means are talking about here
Sir,
this position. This position. That means instead of 5, it should be here.
yes, sir.
Okay. So the result will be, what happened? You told me 4, but the result is 8. That means where it is pushing the element, I have already told. See, 0, 1, 2, 3, 4, 5, 6, 7. It's checking minimum value. Okay, minimum. So see, 6 is less than 7, 5 is also less than 7, 5 is also less than 7, 4 is less than 7, 2 is less than 7. Okay, push it here. But 10 is greater than 7. So don't, but before 10, 7 will be pushed. This is quite logical. Okay, so whatever the values which are less than 7, just go follow all them, and then put them at that particular place. Still now, let me bring some more twist. Copy and paste it here. Some more twist. If I'm having 10 here, 10 here, and if I'm having 1 here, 1 here, where it will be pushed? Where 7 will be now present? Which index position 7 will be present now?
0, sir.
Zero, sir.
Which? 0. Okay, let me run this code. It gave me 9. It gave me result 9. So how it gave me 9? So 0, 1, 2.
Least value is 9. 1, no, sir.
Least value is 1. No? So it should be
Yes,
present
sir.
after 1.
Yes, sir.
Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will, now the concept is clear. Whatever be the least value is, it will place 7 after that. This is search sorting has been performed. That means it is searching for the least value and it is putting after it whatever the least value is.
Sir,
Yeah,
doubt, sir.
yeah,
You
I see.
typed a program, no, sir, before this, and it gave the output as 0, no, sir,
Means
above this program.
you got.
No, sir. You typed a program before this, no, sir, with the numbers 5, 6, 7, 8.
Huh.
And when we gave the input as x equal to np dot set sorted arr 7, it showed the output value 0, no, sir.
Now, yeah, it shows output value 0 above. Now it
What
show,
is
yeah, above it
yes,
show the.
sir.
See, that means after
Why
6,
it showed
after 6.
0 here?
See, the reason is after 6. Is there any space after 6?
No, sir.
So that's why it's shown 0.
It's a,
That's why it shows 0. So I need
and
to place
basic
I need to place
program,
this
there
element.
isn't any
Yeah,
space.
yeah. See, the point is I need to
Yes.
place this searched element up to on next index position. But it is unfortunate that I don't have any place here for the next position. If I would say, for example, if this is, let me copy this code. Let me copy this code. Okay, and paste
Sir,
it here. Yeah. And if I'm having, let's see, I'm
uh,
having 10. Now run this code. Again, it gave me 0. Because the point is, okay, here it is 10. That is more than 6. More than 7 actually. More than 7. 6 actually. So how it's gonna replace it? Yeah, ask the question. Yes, ask the question.
it should 4, no, sir.
Yeah,
After 6.
yeah, after 6. After 6, yeah. That means we are expecting, na?
It
It
should
should be
be.
it should be here after 6.
Yes, sir.
Okay, but it's not been placing the value after 6. It's not doing that. And see, say one more thing. Let me copy this code again and paste it here and take value 6 here. Take value 6. Again, it gave me the result 0. And if I take 9, it gave me 4. Why 4? Why 4? That means 0, 1, 2, 3, 4. This position it gave me. Are we considering the stuff that means index positions, because it's going to return you the index position, and as per the norms also say, as per the norms said, that is it the function returns the index, which means that if 7 is inserted at this index position this, or 6 is inserted at this position index, the sorted order of the array will be maintained. Sorted order of the array will be maintained. So here how the sorted order is going to maintain. Right now we disturb the sorted order. One more thing, let me clear you the fact. When we started learning this concept, when we started learning this concept, okay, initially there was a sorted order. Actually, when we started learning this particular thing, 6, 7, 8 and 9, there was already a sorted order, and it returned 1. That 7 should be here only to maintain the sorted order. If I say where 8 should be present, where 8 should be present, it tells her it should be the second index position to maintain the sorted order. But when I change the sorted order itself, 8, 7, 6, 9, change the sorted order. Now it's interpreting like this. If you run this code, it said 3. Why it said 3? Because the reason it's 0, 1, 2. It told 3 here, this position, to maintain the sorted order. But still, if I place 7 here, the actual value of array is not still sorted. But we told, okay, this is the sorted order, and to maintain it, where to place 7? To maintain it, where to place 7? Okay, so we are to maintain the sorted order, I need to search where it should be actually present. So it returned 3. That means it told that after 6 you can put it here. After 6 you can put here 7. Then again we did some twist. 8, 9, 7, 6. Again we changed the order, and then again asked where should be I need to put 7. So it said 0th index, 0. That means it should be present here. Return the index, because after 6 there is nothing available. So it returned 0. It should be put present here. Again we did some twist and asked where should be 7 present now in this particular string. It said it should be present here. It's at 0th index position. But 6 is present here, and 10 is here. Okay, and if we further want to perform the twist, see, we are doing a lot of experiments. We are doing a lot of experiments to understand what exactly the answer it's giving. But as per the meaning of the function, it says it's going to return you the index position where that particular value needs to be present in a sorted manner, in a sorted way. That's what the fact is. Okay, so it's giving the result as 0, and if I run this code, it's giving the result as 4, where 9 should have to be present. So 0, 1, 2, 3, 4, this index position. So now what does the logic says, and how to understand the logic to get the results are coming to us. Either we are not giving these in a proper sorted manner, okay, that's why we are getting these kind of results. Or the one thing is, first these value needs to be sorted. After sorting, then it will let you know that, okay, after sorting, this particular 7 should be present at this particular index location. So when we started our code, the value is already sorted. The value we gave is already sorted, and it told, okay, it should be present at 1th index position. Here also it 1th index position. This where 8 should be present at 2nd index position, and so on. But if we don't give the sorted value, then there are two things happen. Either it is sorting it and then letting you know that this value should be present at this particular location, case number 1, or rather it is not sorting it, It is just looking for what value is been greater than or less than this particular value. That is case number 2. Okay, let me explore it ahead. We will explore it ahead. Let us check this example also. Again, I got a sorted order 6, 7, 8, 9, and I am saying search it from the right side where 7 needs to be present. So then it told, okay, it should be present at 0, 1th, and second index position. Yeah. If we go to search from the right hand side, 7 should be present at second index position, and if we search from the left hand side, 7 should needs to be present at the 1th index position. We know that. Okay, so this here we are giving sorted order already. Now again, I am having 1, 3, 5, 7. It is sorted order. And if I ask where 2, 4, 6 needs to be present, if I am saying where these values needs to be present, so what should be the result I am going to get? Where 2, 4, 6 needs to be present? It will say 2 should be present here at the 1th index position, 4 should be present here at the second index position, and 6 should be present here at the third index position, something like that. Is it or something else? 2, 4, and 6. It's returning me 1, 2, 3. So 2 should be present here at this index position. Okay, got it. That second index position there is 3. 4 should be present at third index position. What happened? Here x returned to me is 1, 2, 3. So what should be means it's going to return me the indexes now. Here I understood, okay, searching from right hand side is going to give me the index where this particular value needs to be present. But what happened here? Here 2, 4, 6. If I copy this code and paste it here again, okay, and if I only take 2, don't take 4 and 6, just take only 2, and what it's going to give me the result? It said 1. If I take 4, it's telling 2. That means after 3. So this is 0th index, this is 1th index, this is second index. That means it is giving you result, not taking all at one time. No, it's giving you result taking them one by one. That means it's, if you ask where 2 should be present in this particular list, at 1th index position. Over. Then 4, where 4 should be present in this list only, sir, at second index position, sir. Over. Then you will ask, sir, where 6 should be present in this list? Okay, before 7 now, at third index position. Not taking all at once. No, separately. That's why I did here. For example, if you say where 6 should be present, so it's not taking where 2, 4, and 6 should be present at the same time. No, separately it is taking where when these are present in this list. So this is all same. Remember one thing, if you are still having doubts in all these in these codes, the point is we are giving already in a sorted manner. We are giving these things already in a sorted manner. Okay, so once you are giving the sorted manner, then we are going to search that in this sorted list where this element is going to be present. That is why it is search sorted. That's the concept, is search sorted. Okay, so there are many things to learn, there are many things to understand, there are, we need to crack the logic, how it is working. So the definition of search sorted, it's going to return you the index position where that element or the value needs to be present in a sorted list. Okay, and you can do left also, right also. If you haven't mentioned side equal to right, then it is left by default, else it is right hand side, it will trace it from here, else it will trace it from here. Okay, and if you are having now this, let's consider another code, numpy np dot array 41 42 and x equal to true false. And if I would say new array arr x, if I would say arr x, okay, then what will happen? That means I'm going to take what? True, true. That means 41 is true, 43 is true. That means just print all those values which are true. That means I have prepared a list true, false, and I'm available with the array 41, 42, 43, 44. And if I'm saying ARR X, so only true values are being printed 41 and 43. 43. This is true, okay, and this is also true. So 41 and 43 are printed here. Now, again, let us consider another code. I am available with the array, okay, and I created an empty list, filter array, empty list I created. Then I am saying if element in ARR is greater than 42, so okay, 41 not greater, 42 not greater, 43, filter dot append true else append false. So here there will be false, then again there will be false, then there will be true, then again will be true. Okay, and create a new array and print that particular array. So here it is. Here it is. Okay, so you are appending true and false in the filter array. And with respect to the filter array, you are printing the value of ARR. That is 43 and 44. Here it is. With respect to that, you are printing its value. So you can apply this for and if and else also in this array and just apply the logics. Okay, which is greater, which is a smaller or whatsoever. Okay, so though this code is also very simple, not a big deal. Again, if you are going to perform this even stuff, whether the number is even or odd, so again you are creating an array. Here you are creating an empty list, and then here you are applying a loop here, and you are saying if element is divided by 2, that means remainder is equal to 0, append true to the list. So here the number is 1 up, so false will be appended. Here true will be appended, then false, then true, then false, then true, and then false will be appended. So here this array filter array will be your false true false true false true. Then accordingly you are saying update my new array, create my new array. So whatever be the true, only those values are written, false will not be written. So 246, this will be written. Again, same kind of code as we did above, same stuff. Okay, now in the next case again, I guess we have already used this coding part. If array is greater than 42, this is your array 41 42 43 44. If array is greater than 42, okay, then you are going to consider those elements only. Okay, just consider only those elements which are greater than 42. So I'm available with 43 and 44. That's it. We have done this stuff above. Okay, same thing. If array is %2 equal to 0, filter those elements only. We have done this thing above here. But this code is a bit large because we are considering true and false and all these. Here we are not considering any true false stuff. Okay, not going to append anything. It will automatically perform the task. How? If I am available with the array, I am dividing this array, taking the remainder. If it is equal to 0, in filter array, it will give false true. Just push the boolean values, and then using these boolean values to print the values here. All the values which are true, that will be printed. 246 will be printed. That's it. Okay, now in the next example, if I am okay, any doubt here, any doubt in these codes, any doubt, please let me know. Any doubt in this above codes?
No, sir.
No doubt, sir.
Because these are quite simple and you are just using whatever be the boolean values true na, that will be printed. That's it. And here is the logic to print them. And just simply you are using if and else and appending all this stuff. That's very simple. All right. Now, if you want to perform the slicing, okay, again, simple. You very well know how the slicing works. This is your list 1, 2, 3, 4, 5. And here is your list 1 colon 3. 1 colon 3 means I need to take 2 and I need to take 3. And this is your ARR array 2 comma 3. This is your array. It's quite simple. Now, if you are going to perform the slicing, in your array, for example, if I do create a 2D array, this is my 2D array. Okay. And I want to perform slicing like this 1 colon 3 colon 3. What does this mean? 1 colon 3 means 1 colon 3 means take how many rows? 1 to 3 rows. 3 is not 3 is not 3 is not including. So that means row 1 and row 2. And colon 3 means you need to take column 0, column 1 and column 2. You need to take 3 columns and column 3 is excluded. Okay, so here this comma this. Now one more important thing. If they are separated by comma, na, that means you are having 3 rows. See here, row 0, row 1 and row 2. They are separated by comma. And in this you are saying, sir, consider row 1 and row 2. So I'm going to take row 1 and row 2 I'm going to take. Also you are saying, sir, only take first 3 columns, column 3. So you're going to take 4, 9, 5, 8 and 6, 7. That's it. Just these values. Here is your sliced numpy array. This is how you can perform slicing in numpy. A way to perform slicing. Here it's a very simple slicing. 1 colon 5. Okay, so I guess there is not at all issue in doing this particular slicing. Element from 1 till 5. Okay, till 5. That's it. Here also you very well know, starting from 4 till end. Colon 4, that means, sir, starting from 0 till 4. 4 excluding. You very well know about it. This slicing you already done in the list. So it's not a hard deal. If I say minus 3, minus 1, you very well know, sir, minus 1, minus 2, minus 3. So result will be 6, 7. Sorry, 5, 6. Minus 3 is there, na? Okay. So that means minus 3 is this thing, minus 5. Sorry, 5. So minus 1, minus 2, minus 3. And the last limit is excluded. So result is 5, 6. Okay. And if I say 1 colon 5 colon 3, now 1 colon 5 colon 3, what does this mean? 1, okay, it starts from 2. Colon 5, that means it should go till 5. Okay. So this is 0th index, this is 1th index, this is 2nd index, this is 3rd index, this is 4th index, this is 5th index. So I need to go till 5. So 1 colon 5 till 5th index I need to go, 5th excluding. And with a gap of 3. With a gap of 3. So if this is my first value 2 with a gap of 3, the next will be 3, 4, 5. So 2 and 5. So with a gap of 3 also we can print the sliced values. Okay, here gap has been made available to you. If I would say colon colon 2, that means, sir, print the values with a gap of 2, 2. Then it will print 1, then 3, then 5, then 7 with a gap of 2, 2. All the values with a gap. You know about it, this thing and this thing. If I would say, here is my 2D array. If I would say 1 colon 4, 1 colon 4 means, sir, I need to take this particular what? This particular row number 1. So this is row number 0. This is row number 1. Why? Because there is a comma separatable. Here is the comma. So this is row number 0. This is row number 1. So I am taking row number 1. So row number 1 is this. Then I am taking 1 colon 4. That means I need to take column number 1, column number 2 and column number 3. So what is column number 1? Column number 1 is this. This value 7. 2 is this value 8 and 3 is 9. That's it. 7, 8, 9. See, it's not a hard and fast thing. It's a very easy thing. Slicing you are already aware of. Okay, so just you need to find what is the row, what is the column. Okay, just accordingly pick the index values. Okay, so there are, if I say 0 colon 2, then it will take 0th row and the 1th row, and it will take second column values only. Okay, and if I do take 0 colon 2 1 colon 4, then it will take row number 0 and row number 1, and it will print the values for column number 1, column number 2, column number 3, because last limit is excluded. So these are just a sample practice questions for the slicing. Here also, if you are available with this kind of stuff, 3 rows, remember one more, again I am repeating, if you are available with a comma na, that means this is row number 0, this is row number 1, and this is row number 2, because you are available with a comma. And then you are saying 1 colon means consider row 1 also, row 2 also. And here 2 colon means consider column 2 also, and all after 2, consider everything. So here is your slice results. All right, fine. So remaining are these slides. Okay, in the next, I need to update the value of the slicing. All right. So I hope that we will cover in your next class.